Alright, so we're going to talk about intercepts now, and your learning target is I can find x and y intercepts and interpret their meaning in real-world situations, and use x and y intercepts to graph lines. So the first thing we're going to do is we're going to go through some definitions here. And the first definition we're going to do is for the y-intercept, okay? And the y-intercept is the point at where the line, crosses the y-axis. So that first blank there is y-axis. The second definition is just kind of the opposite of that. The x-intercept is the point where the line crosses the x-axis. The x-axis, okay? So here's our key concept here. In order to find x and y intercepts given an equation, the first thing we want to do is write the equation 2 times. Write them twice, okay? And the second step is for the first equation, substitute 0 in for x and solve for y. And then your answer then is going to be the y-intercept. Okay, then the third step is on that second equation you wrote, you're going to substitute 0 in for y this time and solve for x. And then that answer is going to be your x-intercept. Alright, so example 1 is actually pretty simple. The very first thing, we just need to find the x and y intercepts. Okay, we're given a graph here. We just need to find what the x and y intercepts are going to be. And so what I want you to do is I want you to see where does it cross the y-intercept. And we see that's about at that point right here. And where it crosses the x-axis, that's what the x-intercept is about at that point right there. Okay, so it's as simple as that. The y-intercept then, where it crosses the y-axis, is at 1. The x-intercept then, where it crosses the x-axis, is at -2. Okay, that's how we identify it, x and y intercepts given a graph. Okay, example 2 here says use the intercepts to graph the line described in the equation 3x minus 7y equals 21. Okay, so this is where we use our key concept here. The first thing we're going to do is we're going to write that equation twice. 3x minus 7y equals 21. And we'll write it again over here, 3x minus 7y equals 21. Okay. Now remember, the first thing we're supposed to do is substitute 0 in for x and solve for y. Okay. And so if I were to put a 0 here in for x, what's 3 times 0? Well, that's just 0, right? So actually, all we really need to do is cover up all of the terms that are next to your x there. Just cover them up, cross them off, get rid of them. Okay, we don't want them anymore because all it is just 0. And all we're left with then is a -7y equals 21. Now this is super easy to solve, right? All we have to do is divide by a -7 on both sides, and we end up getting y is equal to -3. So your y-intercept is at -3. The second one now, remember the next step is to substitute 0 in for y and solve for x. So we're going to do the same exact thing. If 0 times 7 is just 0, so let's just get rid of that whole set right there. Let's just get rid of it, cross it off. Now we have 3x equals 21. We just divide by 3. And we're left with x is equal to 7. So your x-intercept is 7. Okay, now all we have to do is just substitute or plug those into the graph here. Our y-intercept is at -3. Here's our y-axis, so it's crossing at -3 here. Okay, and then our x-intercept is at 7. So we go over, here's our x-axis, 7 is right at this point here. We put 2 dots there, and then let's just connect the lines, okay? That's all we're going to do is just connect those lines and draw our graph like so. And we've now graphed using the intercepts. And that's all you have to do. Alright, example 3 is a word problem. It says Trish can run the 200-meter dash in 25 seconds. The function f of x is equal to 200 minus 8x gives the distance remaining to run after x seconds. Find the x and y intercepts and graph the equation, and then explain what does each of the intercepts represent. Okay, so let's go ahead and do that. Remember, if you have f of x, that's the same thing as y. Okay, so that's the same thing as y. So instead of writing f of x, I'm going to put y in here. Usually we like function notation, but in order to solve for the x-intercepts, let's just go ahead and use y instead. Okay, so here's my first equation. I'm going to write my second equation over just below it. minus 8x. And for the first one, we're going to substitute 0 in for x. So remember, that just cancels out. Negative 8 times 0 is just 0. And so what we're left with is y equals 200. The y-intercept is just going to be 200. That's as easy as it is. Y-intercept is 200. So we can go ahead and put that little dot on the graph here. And then we do the same exact thing. We're going to cross out y, right? Anything that's being multiplied or divided by y, and then solve for x. Okay, so the first thing we're going to need to do is subtract 200. We got to get x by itself, right? So if we do it from one side of the equation, we have to do it from the other side of the equation. Even though we don't have anything there, we still have to do that. That gives us a negative 200 on the left side is equal to a negative 8x. And then we divide by negative 8 on both sides, and we get 25. Negative 200 divided by negative 8 is 25 is equal to x. And that's the x-intercept there, so we have to go ahead and put that into the x-intercept where it crosses the x-axis. Put a dot there. And we're supposed to graph the line here, so we're going to connect those dots. Just like this. Alright, and we built our graph. Now the last thing it asks us to do is it asks us to explain what the intercepts represent. And the intercept right here on the y-axis, it represents the start of the race. Okay, the start of the race. So y-intercept, I know that's kind of close here, is the start of the race. And the x-intercept, where he has no more distance left, or sorry, she has no more distance left, then the x-intercept would be the end of the race. Okay, and those also could mean the distance left until the end of the race. But that's all we really have to do for this. Hope you enjoyed.